Potential divider circuits, how we define the potential divider circuits when the resistors are used to divide the voltage, what we call them as a potential divider circuits. So main purpose of these circuit is to divide the voltage. So when two or more components are connected in series, we can simply call them as a potential divider circuit. And there's a formula. We will derive formula for the potential divider circuit, and you can use that in exam to work out the voltage across the components. Let's say we have a circuit which is having two resistors. Two resistors are connected in series. So why we call a potential divider circuit? Because it divide the potential, the voltage. So if the total voltage is V, what will happen? Voltage across this resistor is R1 and this resistor is R2. So the voltage here is V1 and the voltage here is V2. The current which will flow, we call that as I. An ammeter is connected to know how much current. So example, the current I flow through the circuit. So if I say, because like we are dividing the potential divider circuit here, like if I use the Ohm's law, I can say that V1 is equals to IR1. And if I use a Ohm's law here, I can say V2 is equals to IR2. And if I use the Ohm's law here, I can say V is equals to IR. And what about R? This R is a total resistance. So the total resistance in series will be equals to R1 plus R2. So if we compare the current, because the current is same, current here, according to this formula, the current will be equals to voltage over R1. And according to this formula, the current is equals to voltage over R2. And according to this formula, the current here is equals to voltage over R. So these are the three formulas of the current. All the currents are same because they are in series. So if I compare this equation with this one, like if I say equation A, equation B, and equation C, if I compare A and B, so what will the formula A? I can say because the current is same, the current which enter and the current which passes through, that will be same. So I can say that V over R, V over R, or V1 over R1 is equals to V over R. Like the voltage of the first divided by resistance of a first is same as the total voltage divided by total resistance. And the total resistance is R1 plus R2 because they are connected in series. So I can say V over R1 plus R2. Why R1 plus R2? Because the combined resistance in series is a sum of individual. If I need V1, if I need the voltage here, so I can say V1 is equals to R1 over R1 plus R2 into combined voltage V. So this is the formula which we can use to find the voltage across this component. That resistance of this component divided by the sum of the resistance of the circuit into total voltage V. Same way, is it clear, this derivation? Any doubt in this? Yeah, it can be either be R1 or R2. The EMF is equals to potential difference, and that, yeah, you that will be equals to EMF is equals to potential difference, and we use that to derive a formula for the combined resistance of the circuit. That is R is equals to R1 plus R2. But in this case, we are comparing the currents to know the voltage across individual component. So if I need the voltage across this component, the resistance of that part divided by sum of the resistance into combined voltage V. Same way, if I want to derive a formula for the other part, if I want to derive a formula for this part, so I'll compare A with C. When I compare A with C, So it will be V2 over R2 will be equals to V over R. So V2 is equals to V. What is R? R is the total resistance, so it will be R1 plus R2. If I need V2, the voltage here, so it will be R2 divided by R1 plus R2 into combined voltage V. So if I need the voltage across the second one, I can substitute the resistance of that part divided by sum of the resistance into combined voltage V. So these are the formulas you will always use whenever you see a potential divider circuit, a circuit which is dividing the voltage. So if a question is what is the voltage across the first component, the formula will be resistance of that part divided by the sum of the resistance of the circuit into combined voltage, total voltage V. And if I need the voltage across the second one, resistance of that part divided by the sum of the resistance into combined voltage V. So this is the formula for the potential divider circuit. Is it clear till this point? Now let's say this is a question related to the potential divider circuit. The question is find the potential across each. So we need a potential here V1 and we need a potential here V2. So what kind of circuit is this? This is a potential divider circuit. How we know it's a potential divider circuit? Because the two resistors are connected in series. So it will divide the voltage. So if I need the voltage across this one. So what will the formula? If I need V1, I'm solving for V1. So if I need V1, it's a resistance of that part which is 12 divided by the sum of the resistance of the circuit. So it will be 12 plus 48 into total voltage. The total voltage is 15. So it will be 12 divided by 16 to 15. And when we simplify this, this will be 4. And then 12 divided by 4, that will make 3. So V1 will be equals to 3 volts. So V1 we work out it is 3 volt, and it is obvious that if V1 is 3 volt, the V2 should be 12 volt. Why? Because the total voltage, the total EMF in a loop will be equal to total potential difference. We can also solve by using a formula, like if we need V2, we can also use a formula for the potential divider circuit, that what is V2? So V2 is a resistance of that part divided by the sum of the resistance of the circuit into combined total voltage 15. So this will be 48 divided by 60 into 15. And when you simplify, this will be 1 and 4, and this will be 12. So that is equals to 12 volts. So V2 is equals to 12 volts. If I know the V1, I can simply subtract from the total, I'll get V2, or I can also use a formula. So this is a potential divider formula we use to work out the voltage across each component. So direct formula, this is a direct formula. And so the ratio of the resistance will always be same as the ratio of the voltage in a potential divider circuit. Like we work out the voltage, it was 3 and 12. So what was the ratio here? If you compare the ratio of the resistance, 12 and 48, the ratio is 1 is to 4. And what is the ratio of the voltage? That is also 1 is to 4. So in a potential divider circuit, the ratio of the voltage and the ratio of the resistance will always be equal. Is it clear, this concept? Any doubt in this? Then we have a variable resistor. This is a circuit symbol for a variable resistor. You can use this symbol, or you can also use the other one. So a variable resistor is having its resistance can be changed, and it can be used in two different manners. It can be a potentiometer, or it can be a rheostat. When we use as a potentiometer, we use all of this parts. Like example, the main purpose is to divide the voltage, and here the main purpose is to change current. So this is a variable resistor which is having one fixed end and two fixed end and a one movable or a sliding contact. And we connected, like example, we can connect two voltmeters, a voltmeter one connected here and a voltmeter two connected here. Two voltmeters are connected. Now, what will happen if the two sections are evenly divided? So resistance is directly proportional to length. If two sections are evenly divided, so as a result, what will happen? The voltage here, example V1 and voltage here is V2. So as a result, the V1 will be equals to V2. Like if it's a 10 volt supply, this part will have resistance, this part will also have resistance. So here voltage will be 5 and here also voltage will be 5. But as we move the sliding contact, as we move the sliding contact, as it is a movable, so is this sliding contact is moved like we move it up. So as a result, now what will happen if total voltage is V, here voltage is V1 and here voltage is V2. So which voltage will be higher, V1 or V2? Which will be a greater voltage? Which voltage will be higher? Is it V1 or V2? Resistance is directly proportional to length. So greater the resistance, greater the voltage. So in this case, V2 will be greater and V1 will be smaller. So when we use the variable resistor to change the voltage across the component, so V2 will be higher and V1 will be smaller. So if we have like here a voltmeter, so this is a voltage input and this is a voltage output. So by moving the sliding contact, by moving the sliding contact from one place to another, we can change the voltage. So what we call this type of use of a variable resistor, we call this as a potentiometer. And we can use a concept here because resistance is directly proportional to length. So if this total length is L, what will the formula when we are using at a potentiometer? If this total length is like L naught or L0 and this length is L, so the ratio of the length and the ratio of voltage will be same. So if I need output voltage, so V out will be equals to length of that section divided by the total length into total voltage. It's the same idea like resistance of that part divided by sum of the resistance into total voltage. So if I need the output voltage of a potentiometer, we'll take a ratio of the length. Say this was say 2 centimeter and this was like let's say 10 centimeter. So it will be 2 divided by 10 into total voltage. If it was a 20 volt supply, so we'll multiply by 20. And when we simplify this, we'll get that as 4 volts. So the voltage output will be 4. So in a potentiometer, when we use a variable resistor, the potentiometer, the main purpose is to divide the voltage. Is it clear, this idea about the potentiometer? Any doubt in this? So using a potentiometer, we can increase or decrease the voltage across a component. But when we use as a rheostat, so advantage of using a potentiometer, that, like say we have, so if we move the sliding contact down and here we connect a voltmeter or a device, here is the voltage output, in this one is the voltage input. So length of this section, and this is the total length. So L and L naught, like we take a ratio. So V output will be equals to length of that section divided by total length into V in. Output voltage could be zero because if we move the sliding contact till the bottom, like if it is connected here at the bottom, so this L is zero. If L is zero, if this factor is zero, so the whole V out will also be zero. The output voltage will be zero. So when we use a potentiometer, we can vary the voltage from zero to the maximum value of the supply. Like the variation of a voltage can be zero till the maximum value of the supply, which is the input. Like if this supply was 20-volt supply, so the range of a voltage which can be used here, it is from 0 to 12. Like I can have 0 volt across the component till the maximum I will have 12 volts. But when we use as a rheostat, our main purpose is to change the current. It will also change the voltage, but the use is we only use the sliding contact and the fixed end, and then the device is there. So the same thing, when the current is passing through, the current has to pass through this length and then going into the device and then return to the circuit. If we change the movable part here, the sliding contact, so the current will also, the resistance will change. Now it has to pass through this length and it will go out. So resistance is directly proportional to length. Longer the section of the wire of variable resistor the current has to pass through, the greater the resistance of the component. But in a rheostat, we can never have a voltage zero across the device, across the component. Why? See, if you have a rheostat, I can draw vertical plane as well. It's not like one is horizontal, one is vertical. It's like in one we use all the three ends, another one we use only two of the ends. So see, it's if it's a 10-volt supply, some voltage will be here and remaining across the lamp. So some voltage will be here, like example two, say this is a 10-volt supply, so maybe 2 volts is here and remaining, it's a 10-volt supply, so remaining 8 volts will be across the lamp. Then we move a sliding contact. Then we move the sliding contact, like say this position. What will happen? Total is 10 volts. So maybe 6 volts is here. So remaining 4 volts will be here. Then we move the sliding contact. So then we move the sliding contact to this position. So even it is at the end, but the total voltage is 10 and there are two components, like the conventional current will move. It has to pass through this variable resistor and then go to the lamp. So if 10 volts is there, maybe 9 volts is here, 1 volt is there. So you can never have a 0 volts in a rheostat. You can never have a 0 volt either in the variable resistor or the component. There will always have some voltage. But in a potentiometer or a potential divider, when variable resistor is used as a potentiometer, you can vary the voltage from 0 to the maximum. So that is the advantage of using a potentiometer over a rheostat. Both are, this is a variable resistor, but the way we connect a variable resistor, we call that as a potentiometer or a rheostat. So this is this is a rheostat. This is a variable resistor or potentiometer. Both are variable resistor, but the purpose, like the way you use in the circuit, that will affect the voltage which is across the component. So if I'm using a potentiometer, we use all the three parts. Okay. This is one complete loop. And the total EMF must be equals to total potential. Like if let's say this was 10 volts. So how much voltage will be here? This will be zero because this is not having any resistance. And remaining 10 volts will be here. When we move the sliding contact, now this might have 2 volts, so this will be 8. When we move the sliding contact at the center, when sliding contact is there exactly at the center, so this will be 5, this will also be 5, like equal. But when the sliding contact is moved towards the bottom, the voltage here, it might be, let's say 7 volts, this might be 3 volts. And when it is on the other end, so when it is on the other end, what will happen? The total voltage here will be 10 and total voltage here will be 0. So if we have any component connected here, that component voltage can vary from maximum till the minimum 0. That is what happened in a potentiometer. But if I'm using a variable resistor as a rheostat, I will draw in the same manner so you will have an idea how it works. So we use one fixed end and we use one variable end, the sliding contact. And it is connected to a supply. And then the component is connected. Like example, a lamp is there or any component can be connected here. Say this is a movable part. Which is there connected at the top. So the conventional current, the direct, what is the flow? The flow will be, it will flow from the positive terminal, then it will flow through the rheostat, the variable resistor, and then through the component. Now, when the charges are moving, like say 10 volts is there. So this is there's no voltage here. So all the voltage is across the lamp. So across the component, maximum value is 10. Now, when we start to move this sliding contact down, if we move the sliding contact down, now it's at this position. So when the sliding contact is at this position, so out of 10, maybe let's say 3 volts is here, so remaining 7 volts will be here. Then when we move a sliding contact further down, because the lamp is also having some resistance, so as a result, what will happen? The total is 10, but that total still will divide between them. Like most of it divide across a variable resistor. If total is 10, maybe 9.5 is here, so remaining 0.5 is here. So across the component, you can never reach a 0 volts when you're using as a variable, when you're using as a rheostat. But when you use as a potential divider, you can divide the voltage and you can vary from 0 till the maximum value. That's how a variable resistor can be changed into a rheostat or a potentiometer or a potential divider. Is it clear, this concept? A variable resistor. So this is a potentiometer. If you are using a potentiometer, you will always use all the three ends. But if you use a rheostat, when you are using as a rheostat, you will not use all the three ends. You will use only two of them. One is a sliding, another one is a fixed end. Any question or a doubt related to the session today?